Alright, welcome. Today we are talking about special right triangles. So basically we are going to be taking what we know about similar triangles. That is that every set of triangles with the same sets of angles have to be proportional to each other. And we're going to apply that to right triangles that have a given set of angles. So in other words, every set of right triangles with the same set of angles will be proportional to every other triangle with that same set of angles. There are two very, very common right triangles that we'll see all the time, and because of this they are known as the special right triangles. The first of which is our 45-45-90 triangle. We call it this because the angles of that triangle are 45, 45, and 90 degrees. Of course, this is also an isosceles right triangle, so you may also see it as that name. We know that for every isosceles triangle, you must have two congruent sides to go along with your two congruent base angles. We also know that based on the Pythagorean theorem, a squared plus b squared equals c squared. So if I take the sides of this triangle, so in this case L squared and L squared, added up, that would give me 2L squared. And then if I take the square root of that guy, it would be the same as L square root 2. So that's where those three sides come from. If you don't like looking at it with the variables, just remember that your base 45-degree right triangle has the sides of 1, 1, and square root of 2. From here we can use proportions to solve for missing sides in these triangles. So if I'm looking at my first example, I notice that I need to find the value of x. I've been given the 45-degree angle, but I've only been given one side of that triangle. So if it's been given that we have a 45-degree angle, and it's been given that we have a right angle, then my triangle must be proportional to the special right triangle, so it must have the proportions of 1, 1, square root 2. So again, using our corresponding parts, 6 over x, 1 over square root 2. So then when I cross multiply, x is equal to 6 square root 2. Looking at the second example, we have two matching sides. So the other side must be proportional to square root of 2. This one we technically could solve with Pythagorean theorem by plugging in 9 root 2 as both a and b and solving for x. But it's actually probably slightly faster to do it with the proportion. So again, we can say x matches with the 9 root 2. If I go over to my base 45-degree triangle, the hypotenuse, which is where x is the root 2. The leg, where the 9 root 2 is the 1. And then, once again, cross multiply. So x is equal to 9 root 2 times root 2. So if we multiply the numbers under the radical, you can think of that as if it says 9 square root of 4. But we know that the square root of 4 is 2. So really, 9 times 2 is 18. All right, that is all for that example. Next up is the 30, 60, 90 right triangle. So like the previous triangle, it's called that because that's what the measures of each angle are. You notice over here, again, if you use Pythagorean theorem with s and s root 3, it should give you 2s. The key to remembering this rather, is that the hypotenuse is always twice as big as the smaller leg. So if I have my triangle like this, and I want to just sort of boil this down to a simple base triangle, I can say that the shortest leg is 1, the hypotenuse is double, and then from Pythagorean theorem, 1 squared plus b squared equals 2 squared. 1 plus b equals to 4. Sorry, b squared. So b squared is 3, which means that b is root 3. Right, so that is where our square root of 3 comes from. Using that triangle, we can solve for the missing pieces of any 30, 60, 90 triangle. So looking at my example, it asks for x and y. It gives me a 60-degree angle. It gives me a 90-degree angle, so therefore I know I need to be able to put a 30-degree angle here. So again, let's draw our base triangle. Let's make sure that everything is in the same orientation as the problem they gave us. We said that 30 degrees, the shortest leg is always 1, 2 on the hypotenuse, and then square root of 3. And now we can see how the proportions line up. So if I want x to 15 is the same as 1 to root 3. So when I cross multiply, x equals 15 divided by the square root of 3. And when we get this, so we can either leave it like that or we want to simplify it. So if I put another root 3 on the bottom, right, think of this almost like finding a least common denominator. Technical term for this is rationalize. The denominator. I do 15 times the square root of 3. Root 3 times root 3 is root 9, which we all know is just 3. And then 15 divided by 3 is 5. So the most simplified version of this answer is 5 root 3. To find y, I'm going to say 15 over y is equal to root 3 over 2. And then we're just going to follow the same steps. So y is equal to 30 over the square root of 3. And then we rationalize it, which should give us y equals 10 square root 3. All right, that's all I have for today. I will see you guys next time.